In this video, I want to show you how you can use complete the square to solve a quadratic equation. So, the whole idea of using complete the square method is to set it up in such a way that you can then use the square root property. So my goal is to use complete the square to rearrange the equation so I have something inside parentheses squared is equal to something else, with x inside here, and x is nowhere else. Once I have it set up like this, then I can use the square root property like we did in the previous examples to square root both sides and solve for x. So that is my goal. So I'm going to use the complete the square method in order to do that. So the first step in completing the square is I want to make sure that whatever is in front of my x squared is a 1. In this case, because it's a 2, in order to get rid of that 2, I need to divide the entire equation by 2. So that's going to give me an x squared minus 4x plus 3/2 is equal to 0. So we just set it up so that my leading coefficient is a 1. The next step to using complete the square to solve a quadratic is to then make sure your constant is on the right-hand side. I am going to subtract 3/2 from both sides, but while doing so, I'm also going to leave a blank here because I'm going to add something in. And whatever I add in on this side, I also have to add in on this side to keep my equation balanced. Now, in order to complete the square so that I have a perfect square, in order to do that, I need to take half of the middle term, which is -4. I take half of that, which is 2, and I square it. So 2 squared is 4. So I take half of -4 and square it. Now the sign doesn't matter because when you square it, it's going to end up coming out to be positive anyways. But whatever I put on this side, I also have to add in on this side to keep my equation balanced. Now I just set it up in a way that I just created a perfect square, x minus 2, x minus 2. That's going to give me x squared minus 4x plus 4. Now on this side, I'm going to get minus 3/2 plus 4. That's going to give me a 2.5, which is a 5/2. Now, I can rewrite this x minus 2 times x minus 2 as x minus 2 squared is equal to 5/2. Now I just set it up like this. So I have the part that's being squared is isolated, and then I have my number on the other side. So I use complete the square in order to set it up in such a way that now I can use the square root property. So I'm going to square root both sides. When I square root both sides, I got to remember to do plus or minus. So that gives me x minus 2 is equal to plus or minus the square root of 5/2. And now to finish solving for x, I just add 2 to both sides. So I have x is equal to 2 plus or minus the square root of 5/2. So I have two answers. I have 2 plus the square root of 5/2 and 2 minus the square root of 5/2. Hey, in this example, we don't have a coefficient other than 1 in front of my x squared, so I don't have to worry about dividing the entire equation by some number. So I can go ahead directly go and start by adding 30 to both sides, and I'm going to leave a plus blank here and a plus blank here because I know I'm going to fill something in there so that I can complete the square. Now, in order to complete the square so that I can factor this as a perfect square, I need to take half of 7, which is 7/2, and square it. When I take, let me do some scratch work over to the side here. I have 7 divided by 2. I take half of 7, and then I have to square it. That gives me 49 over 4. So I'm going to put 49 over 4 here, and whatever I do to one side, I also have to do it to the other side. Okay, now I've got a perfect square here. I can factor this so that I have 7 halves and 7 halves. So when I multiply them, I get 49 over 4. But when I add 7 halves and 7 halves, I get the 7. In order to get the minus 7, these both have to be minus. Now, when I take the 30 plus the 49 over 4, that gives me 169 over 4. When I add those together. So now I can write this as x minus 7 halves squared, because they're both the same thing. I get 169 over 4. Okay, now I have it set up where my part that's being squared is completely isolated. So I can square root both sides. When I square root both sides, I get x minus 7 halves is equal to plus or minus the square root of 169 over 4. Okay, so now I'm going to take and add 7 halves to both sides. Now I'm going to add 7 halves to both sides, so I get x is equal to positive 7 halves, because I'm adding 7 halves to both sides, plus or minus the square root of 169 over 4. 169 over 4, when I square root that, that gives me 13 over 2. That comes out nicely. If it doesn't come out nicely, you just leave it as the square root of 169 over 4. If you can simplify what's under the square root, then go for it. Otherwise, you can just leave it alone. Okay, so I have two answers. I have 7 halves plus 13 over 2, and I have 7 halves minus 13 over 2. When I take 7 plus 13 over 2, that gives me 20 over 2, which is 10. And when I take 7 minus 13 over 2, that gives me a negative 6 over 2, which is a negative 3. Okay, in our last example, we do have a value in front of our x squared that is not equal to 1. So the first step is I need to divide everything by 2 in order to get that x squared to have a coefficient of 1. So that's going to give me x squared plus 2x minus a half is equal to 0. The next step is to get my constant on the right hand side, and I'm going to leave a blank here because I'm going to fill something in. I add a half to both sides, and I'm also going to leave another blank here because I know whatever I put in on the left hand side, I also have to add it in on the right hand side. Okay, now, in order to make this a perfect square, I got to take the middle term here, I got to take half of it and square it. So half of 2 is 1, and then I got to square 1, and I'm going to get 1. So I put a 1 here, which means I put a 1 over here to make sure everything stays balanced. This can be factored as x plus 1 times x plus 1. When I take 1/2 plus 1 on the right hand side, that gives me a 3/2 when I add that up. I can rewrite x plus 1 times x plus 1 as x plus 1 squared. And now I've just set it up in a way that I can use the square root property. So I'm going to square root both sides. I got to remember to do plus or minus. When I square root both sides, the squared and the square root undo each other, so I'm just left with x plus 1. And I'm left with x plus 1 is equal to plus or minus the square root of 3 over 2. Now, I'm going to add, or sorry, I'm going to subtract 1 from both sides. So I get minus 1 plus or minus the square root of 3 over 2. Now, if you want to keep going, you can simplify that and rationalize it by multiplying the top and the bottom by the square root of 2. If you do that, you get minus 1 plus or minus the square root of 6 over 2. I'm okay with either one. I'm not sure what your homework system is going to want you to do, but I would be okay with either one of these. If you don't remember how to simplify square roots or rationalize square roots and factor or anything like that, I have posted videos on Canvas for you to review those topics. So if you need to review those topics, I definitely suggest that you go back to Canvas and watch those videos that I posted.